So previously we looked at stack, right? Stack was a data structure that followed a rule, LIFO. And using stack, we could do certain operations like so these are the things we've looked at, and there are few small operations that you could perform using a stack. For example, reversing a string, checking a palindrome. These are the things you can perform. These are the things you could perform using a stack. And there are other things as well. So before we move to the next topic, do you have any questions regarding stack? If there are no questions, then
স্যার ইনফিক্স টু পোস্ট ফিক্স এই টপিকটা স্যার তো আমরা স্যার হচ্ছে মিড টার্মে হচ্ছে সিমুলেশন করেছি স্যার এটা কি কোনো কোড আছে মানে কোড করতে হবে
no, আপাতত code নাই. There are no codes for it right now. But if in the lab, I'm not sure about the lab.
স্যার ল্যাবে হচ্ছে যে ব্র্যাকেট প্যারেন্থেসিসের
হ্যাঁ, তাহলে আর কোডিং নাই, just simulation. Today's topic is Q. This is another data structure. And it follows a rule called FIFO. That means first in, first out. Opposite to stack. Q is like stack. Q is not a container. Q is basically a concept, a rule that we follow first in, first out. It also uses arrays and linked list. We all know what a queue is, right? For example, bus stop. If this is a bus stop, we stand in a queue for the bus. The first person who's in the line, boards the bus first, right? First in, first out means the first one who stood in the line, or the first person, or the first element in the queue will get served first. This is what the English meaning is of a queue. exactly we're going to follow the English meaning of the queue. The first person or the first element will get served first, and then the second person or the element, then the third, and then the last one. This is the opposite of LIFO. In a stack, the last one would get served first, but in queue, the first one gets served first. All right. So at first, let us look at array queue. So this is a linear array. And currently the queue is empty because there are no elements inside the queue. So the first element comes in, for example, 5. I place it inside the queue and insert in the queue is called NQ. And delete from the queue is called DQ. In a stack, it was called push and called push and pop. And when we'll be using a queue, we'll say NQ and DQ. So this is the first element to get NQ'd. For example, this is my second element, third element, and fourth element. And when we need to DQ, the first element to be DQ'd would be 5. So whenever we DQ an element, whenever we DQ this space gets empty, right? The next time we DQ, the number would be 7. 7 would be deleted from the queue. Let us NQ another number. Let's say let's NQ 11. Now let's NQ another number. Let's say I NQ 13. Now look, there's a problem over here. If we want to NQ another number, let's say 15, there are no spaces left. No spaces left. But is it true? I have 2 empty spaces at the very beginning, but the way we are NQing the numbers, over here there are no more spaces. Therefore, I cannot insert 15 over here. But there are empty spaces in the array. If I NQ 15 over here, and if we DQ, the number DQ'd would be 15. And that would be something wrong. Now this is a problem with the queue. Like if we use a linear array, spaces at the beginning, at the front, will be wasted. If we DQ, we'll DQ 8. If we call the method DQ again, 9 will be deleted. So I'll have spaces in the front. Still, I cannot add elements at the rear because this is a linear array. Now, this problem can be solved if we use a circular array instead of a linear array. We could solve this problem using a circular array. Let's see how. So we know circular array has a pointer called start. Initially, the start is -1 because there are no elements inside the queue. So I NQ the first element and my start points at 0. I NQ the second element. I NQ the third element. And let's say we call DQ. When we call DQ, the element pointed by the start will get deleted. When it gets deleted, I will change the start from this index to this index. Because when we are deleting this element, the next element to be served is this element. Therefore, we are changing the start from this index to this index. So let's say we call the DQ again. The element pointed by the start will get deleted and the start will be incremented by 1. Let's say we NQ more numbers. So I NQ 8, I NQ 9, and I NQ 10. Now if I NQ another number, let's say I NQ 11, I can easily NQ it in this index. Because this is a circular array. And we know circular array, we can use it in this manner. So when we run out of space in this direction, we can easily use up this space. And when we call a DQ, which number will get deleted? The number pointed by the start. So my sequence does not change. I call a DQ again. 8 will be deleted. So my sequence is not changed. My last number is 11. Now if you DQ all the numbers, the last number to be DQ'd will be 11. And I am not wasting empty spaces. So at this point, if I NQ more numbers, let's say I NQ 12, I NQ 13, I NQ 14, no problem. If I call DQ again, the number to be DQ'd will be 9, pointed by the start. So using a circular array, I can address this problem of wasting spaces. I can avoid this problem and the sequence will not be broken. Therefore, I can use a linear array, no problem. But using a linear array will waste a lot of spaces. To avoid this problem, we'll use a circular array. All right? And we know how circular array works. So you might get a question in the exam where we will ask you, we'll ask you why do you prefer a circular array over a linear array while using a queue? Okay, so your answer will be to avoid wasting spaces and my sequence will not be broken. And the code for NQ and DQ is same as inserting and deleting element inside a circular array. So I'm not writing the code. You can insert and delete elements from a circular array, right? Same code. In fact, queue is even easier because there will be no shifting. You'll not be inserting or deleting elements in the middle. You'll be always inserting or you'll be deleting from the start, and you'll be inserting element at the end. So there are no headaches of shifting. All right. Okay, now let us look at a queue using a linked list. Very simple. You may use any linked list you want. So I'll show you the simplest one using a single link circular. Single linked list. You may use any linked list you want, but you do not need a circular array, circular linked list, right? Circular linked list is not needed at all. So initially, when the queue is empty, my head is null. When we insert the first element, let's say I'm inserting the first element is 5. So I create a node. I create a node with the element 5, and this will be my head. Let's say my next element to be inserted is 6. So I simply create a node with the element 6 and link it with the previous node. Similarly, if I keep on adding elements in queuing elements, I will add a node one after another. Now, when it comes to DQ, simple. We will delete the head because this was the first element to arrive at the queue. So I'll delete the head, the element at the head, and then change the head. If I DQ again, delete the head, change the head. If I NQ another element, simply add it to the end. So while NQ, then change the head. So this is basically what a queue is. Queue is the opposite of stack, and queue is not a container by itself. We use a circular array and a linked list to implement the rule of queue, that is FIFO. And we use queue in our real life. Everywhere we go, we stand in a line. The first one to arrive will get served first. The last one to arrive gets served last. So this is what a queue is, all right? So if you do not have any questions, there is nothing more to explain in a queue.